Hello, everyone. I'm Dr. Wang. Here is the question. I equals square root of -1. This is not the real number. It is an imaginary number. We want to find the sum of I plus I squared plus I cubed plus until I to the power 2022. The first idea is natural because it is easy for us to see that I square, I cube until I to the power 2022. Those terms are from a geometric sequence. So the first method is to use a geometric sequence, the sum formula. That's a formula. So we can plug in all information from the given condition here. N equals 2022. Now the question is how to simplify I to the power 2022. I square equals square root of -1, then square equals -1. I to the power 3 equals I square times I to the power 1. I square, we have -1 here. -1 times I equals -I. I to the power 4 equals I square then square. I square we have here -1 then square equals 1. This is a very important result. I to the power 4 equals 1. I to the power is a function, periodical function. The period is 4. 4 come back to 1. So here we can use this property to decompose the power 2022 into 4 times 505 plus the remainder 2. The first part we can rewrite into I to the power 4, then to the power 505. Then times, we have 2 left here. That's I square. Because I to the power 4 equals 1. 1 to the power 505 equals 1. 1 times I square equals I square. This is the result for I to the power 2022. I to the power 2022. Replace I to the power 2022 by I squared. So here, 1 minus I squared. We can factor this as 1 plus I, 1 minus I. We have 1 minus I in the denominator. We can cancel. We have I times 1 equals I times I equals I squared. What is I squared? I squared equals -1. I minus 1 is the result. We use the second method. This is a simple factor. The sum of first consecutive terms is 0. I, second term I square equals -1. I cube, we already derived that's -I. I to the power 4 equals 1. The sum of first consecutive terms, that's 0. We claim sum of any consecutive terms equals 0. Whatever you can't start from middle, beginning, or backwards from the end. Here's the simple proof. 4 consecutive terms This is a sum. K can be anything. We can factor I to the power K out. The first part, you have I to the power 1. Second, that's I squared, and so on here. This part, the second part, we already derived. That's 0. So that's 0. We proved sum of any consecutive terms equals 0. So here, look at the given question here. How many 4 consecutive terms in this sum? We decompose 2022 into 4 times 505 plus 2 terms remaining part. So here we count from the backwards, from the last one, each 4 as a group, each 4 as a group. The sum of 4 equals 0, then the first 2 are the leftovers. So the sum equals the first 2, I plus I squared. What is I squared? I squared equals -1. We got the same result. That's all. Thanks for watching, and see you next time.